Guys, welcome. Thanks for attending. Great to have you with us. My name is Simon, and during this period when our training centres are closed due to the UK government's COVID-19 guidance, we are providing live training sessions on various topics to help you to continue to progress through your course. We're all centre assessors on here, and during these difficult times, you're going to have us beamed into your homes. Now, please remember throughout the lesson to take notes. It's really important that you take notes. During the session, we're going to be asking some questions that you'll need to answer. So please stick with it and keep those notes flowing. You may also end up using them in the future as well. During these difficult times, there is high usage of the internet. So if I cut out a little from time to time, don't worry. The internet is just pretty busy at the moment. So even if the picture of me drags a little bit, you'll still be able to hear me. So stick with it. It'll be worth it. Unfortunately, there's not a great deal that we can do about the internet itself, but hopefully it won't cause you too many issues. On the subject of all things IT as well, if you've got pop-up blockers or ad blockers on your machines, it's possible that the video that we're going to show you won't necessarily play. Now, if you do find that's the case, no panic. You'll be able to refer to the recording of this session that will appear on Student World shortly, so you won't miss out on any of the information whatsoever. So guys, today we're going to have a look at the soil stacks and traps and preparation for your 209 GOLA. Now, we're going to run through some of the detail about this and what that assessment involves, but we want to run through some of the components and the sizes and some of the numbers that are associated with this topic. It's quite an intense little exam, this one, so it's not just about remembering the names of the pipes and so on. There's some numbers and formulas and such like to remember. So we want to give you some of that information today and give you some pointers as to where you can go and where you can find this information, some of the key pieces of documentation that you'll need to refer to. So there's lots of information to take on board in preparation for this assessment. So like I say, keep taking those notes, take down that information and take note of where you can then move forward for your revision and your studying. So let's have a look. Let's pull this up, and then we're gonna have a look at this beast behind us here as well. So let's have a look. So first things first, we are going to introduce you to soil stacks, traps, and testing. Now, I've got a very, very small soil stack here, but that doesn't matter. The process is going to be exactly the same. So we want to show you the soundness testing procedure and setting up of the equipment. We're going to talk to you about traps and the water seal inside them, give you some of that terminology, talk about some of the problems that you can get with losing trap seals and how you can overcome some of those things. So soil stacks, traps and testing. Let's just move on to the very first slide here. Just again, it's just that overview. What are we doing today? The purpose of this lesson is to provide an introduction to soil stacks, traps and testing. Crucially, this is important for, so you've got two assessments at level 2. You have a 209 GOLA exam. Now that GOLA exam will cover lots of different things. It's going to be system design, it's going to be components, it's going to be testing procedures, it's going to be the equipment that you use, the commissioning of these types of systems. So you'll need to know those things. Now, when it comes to your practical assessments, you need to undertake a full air test. You're going to be using a manometer like this one here. And we're going to show you, let's say, the setting up procedure of that, the why and how we do that. But so you will need to do that on a full size soil stack in the centres. It doesn't matter if it's only this small here. The process, like I say, is exactly the same. But also your GOLA exam is going to talk to you about the design of soil pipes, the branch pipes that we have here that go to the appliances, the traps and the seals and so on, and all the other bits that go with it. You're going to be asked lots of questions about that. So like I say, you need to know these revision points, where to go, where to take that information. And we want to talk to you about some of those bits today as well. So let's just pull up the next slide on this one and introduce you to our friend, the trap. Now, so I've put some images on there just so we can show, and I'm going to talk you through one on here as well. Now, what's importantly, I think here again, is about terminology. It's about making sure that we're talking about the right things. We're talking about the same thing. Now, a lot of people call them U-bends. That's an old phrase. We don't use that. People still do as a natural term, if you like, but it's not the correct technical term. You won't find that in an exam or an assessment. We need to refer to them as traps. And they come in different shapes and sizes. I've put a couple of examples on there. We'll put a P and an S, and we'll talk to you about those in just a moment. So what does it do? The trap contains a seal of water that prevents the sewer gases from entering the building. Anyone who started taking any of these apart or worked on any of these will know it's not a good thing. So lots of PPE, they don't smell very nice at all. So with the natural operation of the system, we need to make sure that the traps are installed on each of the appliances so that those nasty gases then don't come back into the building. I've given you 3 examples on the screen there. So the one on the left is a P trap. I'm going to talk to you about that in a minute because I've got one here behind me. A P trap, because of the shape of the trap, it looks like the letter P. The middle one in the middle there is an S trap. Don't need to explain the shape on that one, but it serves the same purpose. And the one on the right-hand side there is a bottle trap. Again, it's the same thing. The design is slightly different, but it's doing exactly the same thing. They all hold a seal of water on the inside. And that seal of water, of course, we said, stops the nasty gases coming back from our drainage system that the soil pipe system is connected to, which in turn would then come back up through into the domestic property. So what we want to talk to you about then is, first off, is the trap itself and the seal of water that's on the inside. We know why it's there. That's important. That's really important. You are going to be asked about that. There's no doubt about that. So we know why that seal of water is in there. You need to measure them. When you go later on into the subject, you're going to talk about testing them and making sure that the seal of water stays in there. If you're moving on to your level 3, they'll even talk about you'll have to do that. You'll have to do that commissioning procedure as well. So this understanding of the system is crucial at level 2, so you know where to take that. Let's show you first off what we mean. I'm going to just pull up a slide and then I'm going to show you on the trap itself what we mean by the trap seal and what we mean by that water inside the trap. Just pulling up the next slide on there, we can see we're going to refer to it now as the effective trap seal. So it's not all of the water that's in the trap. I'm going to talk you through that on this particular one so you can see exactly what we mean. But we can see that here on the screen. So it's not all of the water in the trap. It's the amount of water that's retained in the trap after operation. If we discharge an entire appliance, that's going to take some of the water away with it. And it's important that it retains a minimum amount, and that's what we want to run past you today. So this must be tested in accordance with BS 12056, and it must retain a minimum of 25 millimeter seal after 3 tests. Now, just to show you on the diagram there, we can see the effective trap seal is not all of the water. It's from the overflow side on the outlet side of the trap through to the top of the dip. I'll show you that on this one in just a second. Now, when you test these, you test them with a dipstick. So that is a matte black painted stick that is inserted all the way down through the appliance and through into the trap itself. It goes to the bottom of the trap, but then we must deduct the diameter of the pipe. And that will tell us exactly what the effective trap seal is, the amount of water that's left in the trap once discharge has taken place. So if we come back over to here, let's just come over to here and we're going to show you on this one here. So here's my trap. So we said on there, it's not all of the water that's in there. It's from where it will, hopefully you can see that there's a line on there now. So where the water, just on the outlet side of the trap, and that will be on the same level on this side. We might just be able to see those couple of lines on there. If not, no panicking, still on that diagram. And we measured down to the dip of the trap just there. The rest of the water down here is not part of the seal because, of course, if it goes any lower than that, the gases are allowed to come back into the property. So it's that distance there measured by a matte black dipstick inserted all the way down, and then we deduct the diameter of the tube. So some key facts and figures. Make some notes of these, guys. You need this for your exam. Appliances connected to a soil stack, albeit mine's very small in this case here, need to be of a deep seal trap. That means they will have a 75 millimeter seal, and that's from the top of the water again down to the dip. So that's the effective seal. Will be 75 millimeters. There are two exceptions, and that is a toilet, which only has a 50 millimeter seal, and a bath, which also is permitted to have a 50 millimeter seal as well. Every other appliance will have a 75 mil. We refer to it as a deep seal trap. Now, in terms of testing, what we would do, every appliance on the soil stack needs to be discharged at the same time. So the installation, this is when it goes in. So this is part of the commissioning procedure. Every appliance needs to be discharged at the same time, and it needs to be done 3 times. And after that test, there must be a minimum effective trap seal left in that appliance of 25 millimeters. So that's putting the system through its absolute or worst case scenario. So 3 times the whole installation to be discharged, and then with a minimum trap seal remaining in there of 25 millimeters. There's certain reasons why we could lose that trap seal. It's possible that we lose that, and that's where customers might complain to you that we've got a nasty smell coming back into the property, purely because we've lost the water within here. Now, this is important again for your assessments. You will almost certainly be questioned about this. So there are reasons why that will happen. The most obvious is that if we don't touch the appliance for 10, 12 weeks, it's open in the summer and it gets hot and it evaporates. That water in there will go, and it will allow then those nasty gases to come back in. So that just means topping up the trap. But the key thing here is about the installation and the design of the installation. This is a 40mm trap and a 40mm branch pipe that's connected to the soil pipe here, which serves something like a sink or a bath. With diameter, you need to make sure you restrict the length that it can be installed at. Now, all of this information you'll find in Building Regulation Document H. They're a free download at planningportal.gov.uk, and also in 12056, as we mentioned there, one of the British standards. Now, with a 40mm waste, you restrict that. That could be no longer than 3 meters long. If we start going longer than that, then we have to increase the size of the pipe, the diameter of the pipe. And that's the same for all diameters. So there's these limitations are in place to prevent what we call induced self-siphonage. Induced siphonage is when we have another appliance, and we'll talk to you about that. So self-siphonage, if this length of pipe was too long, if the diameter was too small and doesn't comply with document H and 12056, then what can happen? We can get a vacuum forming in there if the water discharges too quickly, which of course can also happen if the gradient of the pipe is too steep. So if it's running down at a very, very steep angle, it can pull the water out of the appliance too quickly. And that can cause a vacuum in here, which then pulls the water out of the trap. So the things you need to remember are the gradients of the tubes. Again, all available within those documents. There's quite a lot to remember on those. It's worth researching those. The length of the tubes need to be restricted. To give you some key figures, a 32mm pipe can be no longer than 1.7 meters. 40mm pipe, as we said there, would be no more than 3 meters. If we're talking about a toilet with a 110mm pipe, the type that we would have here, then that's up to 6 meters. Of course, the longer we go on that, then we have issues potentially of losing the trap seal. So gradients, lengths, and diameters, all things to be taken into account. And then, of course, the things that you would put in place to affect that, to change that, should that come up on an assessment, or should it come up as a fault finding job round at a customer's property, then we know how we can do it. We can vent these. We can actually install a vent pipe here and take that up and put it into the top of the soil pipe. We can change these traps. We can put what we call an anti-vacuum trap in, which has a little valve that will open if a vacuum occurs inside the system. What we can also do is put what we call a waterless trap in. I'm going to show you a little bit more about that in just a moment. So we're going to leave our little rig just for a minute. I'm going to show you the setting up of the soundness testing equipment in just a moment. But I just want to run through just quickly on the waterless traps. We mentioned there as an alternative way of being able to do this and to correct an issue if we do have a situation where we have a soil pipe that is pulling out the traps, then this is a way of going about doing it. So on the screen there, we'll talk about waterless traps. So these recent innovations have led to a development of traps that do not have a water seal, but they still need to have something that prevents those smells coming back. So it's beneficial in situations where trap seal loss is occurring. When we spoke about trap seal loss occurring there by being pulled out by self-siphonage, if the pipe is too long, if the diameter is too short, is too small. They also allow unvented hot water cylinder D2 pipes to be connected to a sanitation system. So again, these recent innovations have allowed for unvented hot water systems to be connected to the main stack. And we do that by protecting the D2, which is the waste pipe from an unvented system, by having a waterless trap on there. I'm going to show you a video. Now, this is from a company, it's an American video, but the process and actually the item itself is exactly the same as those sold in the UK. We call it a HEP VO, they call it a HEP VOS, but it's exactly the same thing. maybe even by the same company. So I just want to quickly run through this and then we'll have a chat after.
Introducing HEPVO, a revolutionary sanitary waste valve which replaces a P-trap where space is at a premium. As you can see here, when water enters the valve, the self-sealing membrane opens. As the water stops, it closes again to prevent foul-smelling odors from coming back up the pipe and into the room. Because HEPVO is waterless, it allows air into the drainage system when pressure fluctuates, improving drain system ventilation. In the case of RVs, this means the small air admittance valve, or check vent, is no longer required, simplifying the installation and generating even more space. Sometimes regular P-traps can lose their seal due to evaporation, siphonage, or movement, but because it doesn't rely on water to make a seal, this isn't a problem for HEPVO. So for a sanitary waste valve that won't leak, gurgle, or crack, buy yours online today at hepvo.com. Plumbing wholesalers and RV dealers, please contact asm.com. HEPVO, it won't let you down.
Okay, so interesting there. So that I know they're talking there about sort of mobile vehicles, but they're perfectly acceptable to use in properties as well. No issue with that at all. And it would lose that issue if we find that we have got trap seal loss and that water seal has been lost from there, then a HEPVO trap or waterless trap would satisfy that. They also take up significantly less space as well, which helps with the likes of baths where you've got limited space underneath anyway. Now, we mentioned about self-siphonage, where if this discharges too quickly because it's too long or the diameter is too small, then it can draw its own trap seal out. We mentioned briefly about something called induced siphonage. So generally, as a general rule, these branches here will have nothing else connected to them. That's a branch solely for that appliance. Now, what people will sometimes do is that they will connect a second appliance into one of these. And if that's running very, very quickly, that can also create a vacuum inside the installation. And that vacuum can then lose this trap seal in here. You might recognize that if you've been in perhaps a public toilet where you've got combined appliances. Basins are a good example of this, and you run one and you operate one of them and then you hear a gurgling sound occurring in others. That's induced siphonage. If it's got just one appliance on its own and you discharge it, and when it finishes discharging, it gives you a nice gurgling sound, that's self-siphonage. That's that vacuum occurring on the inside and it's trying to pull the trap out of there. So stick to all the design restraints of 12056 and building regulation document H, and you won't have that issue. So now what we need to just quickly talk about is the soundness testing procedure. Now, this is something that you need to know theoretically, but you also need to know from a practical point of view, because you are going to assemble this equipment and you are going to undertake a test on your installation. The soundness testing procedure is nice and straightforward. Basically, we bung up all of the ends bar one. And that one I'm going to leave at the moment is the top one here. And we're just going to show you, we're going to connect the test equipment to that one. So in this one here, here's one I made earlier. I've inflated a drain testing bag and I've put that inside what would be my branch for my toilet. Now that's just been done by a hand pump, but that creates a nice seal on the inside of that pipe there. The other type of drain testing bung that we have is a mechanical one. So it's got a little wing nut on there that I turn around. It's got two plates, okay, one top and bottom, and a rubber seal around here. So as I do this nut up here, it compresses the two plates together, it compresses the rubber, and that creates a seal on the inside. The advantage of the bag is that it will take up any imperfections on the inside of the wall of the pipe itself. So if there are lumps and bumps or anything, then that will mold around that. These aren't always as successful. It's also better to have the ones that have got metal plates rather than the plastic ones that don't tend to last as long. But quite simply, we're going to bung all the open ends. So we've got that in there, in the bottom there, and all I'm going to do is just turn. There we go, and we just turn the wing nut just until, and that's nice and solid in there, and that's now created a seal at the base of the stack. Now, what would be a good practice at this stage would be just pour a small quantity of water down the stack, and that just gives a little bit of a seal around there. So if there are any imperfections on there and that hasn't taken it up, that water then will create that little bit of seal for you. All traps need to be full of water. Remember, 75mm as a deep sealed trap, and that's before the commissioning testing and making sure that it retains 25 after that. So that'll have 75mm of water in there, and every other appliance, with the exception of the toilet and the bath, don't forget that will only have 50mm seals, will all be full of water. Then what we do is we have an arrangement of tubes. Let me just pull this one round here for you. So quite simply, I've got another drain test bung at the top. It's exactly the same as the one that we've put at the bottom. And connected to it is just this hose here. There's a lot of pipe to see there, but all you need to do is just know that that connects onto the top of the drain testing bung. It then comes down to a Y piece, and that splits two ways. So here we go. Here's our little Y piece just here. One goes to this little manometer here, this little U gauge, and we'll talk to you about that in just a moment. This is a gauge that has two columns of water, or one column of water in a big U shape, hence its name. And it's zeroed so that the two levels of water are just at zero, which is halfway down the gauge. On the other side of that, connected, is a hand pump. You'll be familiar with these sorts of things. And what we do is, with everything sealed, we then just simply, we would pump up, and we put a sufficient amount of air in the system so that on this gauge, we have a reading of 38mm. As the pressure on the system side increases, the pressure of air will push down on this left-hand side of the gauge here. So on this side, the water will drop, and on this side, the water will rise. And we do that until the difference between the two is 38mm. Now, because it's a tube, you get what we call the meniscus, which is like the curve. It's the surface tension of the water. So we measure from the bottom of the meniscus on both sides. So 38mm, and it can only be 38mm because two of the traps, as we know, are not very deep. The bath and the toilet with only a 50mm seal. If we start putting too much air in there, the air then just blows through that. So you pump that up until you've got that reading on there. I can show you a diagram of that in just a moment. And then in this case here, some of them have got a little valve. In this case here, we just pinch that one closed. There we go. And that then stops any air from coming back through here. The key thing to remember at this stage is that to comply with the British standards and the building regulations, that test must hold for a minimum of 3 minutes. There can be no drop. You can purchase what we call leak detection fluid, which if you do find that you're losing air pressure, you can then go round and just see if you've got any bubbles of air coming out of some of your sockets. Let me show you a picture of that just to clarify, and then we get your thinking caps on and we'll have a look at the set of questions that we have for you today. So let's just bring this up here. So soundness testing. So there we go. Now that diagram is exceptionally small, so I do apologize for that. I hope you can see that. But this is available in, like I say, all the documents that we've already mentioned, all the study material as well. Basically, what it's highlighting is that every outlet within the soil pipe itself needs to be sealed. Water in the traps, bung at the bottom, and then the U gauge connected to an appropriate part of the stack. In this case here, like mine or my one on here, that is at the very, very top of the stack. And that's all it's doing. We're then just exerting pressure inside the system. And don't forget that that pressure is exceptionally low. We don't put very much pressure in these at all. They won't hold that level of pressure. We don't fill them up with water or anything like that. So 38mm water gauge is how much they need to hold. One other key fact just to bear in mind just before we do the set of questions is that the termination of the soil pipe. The soil pipe, if it terminates externally on the side of a house and it's near a window, you need to bear something in mind. If that is within 3 meters of an openable window, it needs to be 900mm above that. So that's a key fact to remember. So an openable window or an opening on the side of a building, it can't be next to that because otherwise the nasty smells from that. We've kept them outside of the building by putting water in the traps, and it's going to go straight through into the window. So therefore, anything then within 3 meters, the soil pipe terminates 900mm above that. Okay, right, so just a handful of questions on this one, guys, just to test your learning, and then you've got lots of revision to do in preparation for your assessments. Okay, so as we've done, you might have done some of these before. If you have, then just click away on the question, on the answer that you believe for that question. If not, if you haven't done one of these before, we're going to read them through and just click on the answer that you think is most appropriate. So number one, the effective trap seal is all of the water in the trap. Is that a true or a false statement? Think about where we showed you the lines. So the purpose of installing a trap to an appliance, is it to prevent sewer gases from entering the property, or is it to make sure sanitary appliances operate quietly? Again, think about the purpose. Why is it there in the first place? Number 3, all effective trap seals are the same. Is that a true or false statement? Again, think about that commissioning procedure. So how many times must a sanitation system be tested to ensure that the trap seals are maintained? Do we do it twice or do we do it 3 times? Let's not forget the British standard 12056. So after testing, the minimum trap seal that must be maintained is at 75 millimeters or is at 25 millimeters. We put it through its worst case scenario, the big test. The required soundness test pressure for a soil pipe, 38 millimeters or 38 millibar. Have a think. And last but certainly not least, so how can an unvented hot water cylinder be connected to a soil pipe? Is that using a P-trap or via a waterless trap? Again, think about that video that we showed you. So submit those and then we'll just quickly run through those, a nice summary, and then point you in the right direction, and then you can get that studying underway. So the effective trap seal is not, absolutely right, we put false on there, it's not all of the water. We know that. We don't include the bit at the bottom of the trap. The purpose of a trap is to prevent sewer gases from entering the property. Absolutely right. When you've done a few of these, you'll know why as well. So all effective trap seals are the same. Of course, it's a false statement. We've already mentioned that a WC and a bath is permitted to have a 50 millimeter seal. Okay, so absolutely right there. We've got that the system needs to be tested 3 times. And again, that's to ensure that the installation, we know, complies with the current British standards. Trap seal, I put 75 and 25 on there, just sort of throw you off the scent. 75 is a deep seal trap for installation onto a soil pipe, but once it's been put through its paces, it must maintain a trap seal of 25 millimeters. And of course, same on here as well, just to sort of put those units of measurement in. The test pressure is at a linear measurement, it's millimeters. It's easy to get confused on this one because millibar, of course, is a measure of pressure. So it would be easy to think that that is it, but it's a linear measurement that we're using on the gauge. And of course, a D2 pipe from a hot water cylinder can, of course, be connected to a soil pipe using a waterless trap. That means then that could operate. You don't need to find an external wall for that. And you'll know when we do hot water and unvented hot water in particular, you'll understand the reason for that. So guys, thank you for attending. Brilliant to have you with us. And before you go, I just want to give you a bit of information. We have got more live internet sessions available, but we're just waiting to hear the government's announcements, which are due on Sunday, the 10th of May, before making the next set of live sessions available for booking on Student World. So on Sunday, the government will announce a meeting of the current restrictions, and we need to see what the government is going to announce in regard to restrictions to educational settings. However, please be assured that if the restrictions are not lifted for all educational settings, then we will continue to provide additional services and facilities, as well as live internet training sessions to our students. So guys, please stay indoors, stay well, and stay safe. Take care.